Hello, forensic science students. We have about 3 weeks left in this marking quarter. In fact, that's going to actually wrap up this half-year course. We have taken a little look at the importance of physical evidence, how we cannot count on eyewitness testimony. And so the physical evidence that we've looked at so far include fingerprints and hair. This week, we're going to take a look at fiber evidence and its importance in a crime scene. So I have a little PowerPoint that we're going to go through. The PowerPoint is also on my class page. You can use that to fill in the notes if you want to. Let's start here with our slideshow. Can I just do it this way? So it says fiber evidence cannot identify an individual, but it does provide supporting evidence. Hopefully you remember that this is called class evidence. Class evidence does not 100% say this person owned this fiber, but it is one more piece of evidence that can be used to place this person at the crime scene. It's used as supporting evidence. Matching fibers can place a suspect at the scene of a crime. Before we look at that anymore, let's take a look at what exactly is a fiber. And the fiber, it's not, if you look in the upper right-hand corner, fiber is not that entire chunk of pink yarn. Instead, the fiber is one tiny little fuzz sticking off of that pink strand of yarn. So I've got a piece of blue yarn here, really big blue yarn. The fiber that I would be concerned with would be one tiny little strand that I would pull out of there. So it's the smallest unit of a filament material. So really, we shouldn't even call it a fiber. We should be calling it a filament. So if we take a look at this, the fibers are considered a form of class evidence, can be linked from the clothing of a suspect to the clothing of a victim. Or fibers can be found in somebody's hair. They can be found on our fingernails. We watched that video, or you watched that video that Jessica Knott, the young girl who was abducted by her neighbor and he used his dog to draw her in. She had fibers of his carpet from not only his house, but also from inside his car. Those fibers were found on her body. So looking at this picture, if we look at this guy, Stephen Lawrence, possibly there could be a blood stain that matches his blood could be found on the bomber jacket of Gary Dobson. And that would link those two together as class evidence. Well, a blood stain would contain DNA. So that would be more than class evidence. That would be individual, but that blood stain would be in the fiber. Next one here, fibers can also transfer from a fabric source, such as a carpet or furniture at a crime scene. This guy's using a black light. Locard's exchange principle. I had written on my class page, hopefully you remember what Locard's exchange principle is. It's vital to keeping this in mind when you're processing a crime scene. So when two people come into contact, or when contact occurs, the possibility exists that a fiber transfer will take place. It doesn't always take place, but there's a high probability. If there isn't a transfer of fiber, there's very good chance that there's a transfer of hair or of skin or of some other body fluid could be transferred. That's Locard's. So emergency personnel, medical examiners, and the forensic scientists must handle the victim's clothing very carefully to minimize the loss of evidence. Now, fiber, a little tiny strand, could be easily overlooked. If somebody's talking, they could easily, their breath could blow that fiber strand away. So they want to be very careful at the crime scene to not minimize that loss. And you can see that they folded up a piece of paper so that tiny little strand would be placed in the piece of paper, folded up in there, and then it would be put into an evidence envelope. The type of physical contact between a suspect and a victim can determine the amount that's transferred. This kind of seems like common sense. If there was a violent physical struggle, there's a really good chance that a lot of fibers would be transferred. However, if it was just kind of a casual passing, or if it was a shooting, there might not have been enough physical contact for fibers to transfer from the perpetrator to the victim. However, if they fell onto a carpet or a piece of furniture, there could be a transfer of fiber either from the victim's clothing onto the furniture or the floor, or vice versa. So how a fabric is woven, it's going to affect the number and types of fibers that could be transferred. What do we mean by woven? Well, we're talking about the weave, the threads actually being woven together on a loom. So a tightly woven or knitted fabric is not apt to shed. However, a loosely woven fabric is more likely to shed. You can see there's a much tighter weave on the piece of fabric on the left, whereas the fabric on the right is much more loosely woven. Think about a hair braid. If you were to braid your hair into a really, really tight braid, you could exercise, you could probably even sleep on that braid, and it would still stay tightly woven together. However, if you do a real loose braid in your hair, a little bit of exercise, and especially sleeping on it, causes it to get pulled out. Same thing with the weave of a fabric. We got 5 properties of fabrics that we're going to take a look at. And the first is the color. Now, when we say that something is the color red, well, there are hundreds of shades of red. And the way that they get those different shades of red is by mixing in maybe a little bit of blue, a little bit of green, a little more yellow, which would give it more of an orangey color. Or if they add the blue, you're going to get a little more of a purple tint to it. Dyes and discoloration can make fabrics more useful for identification. A forensic scientist, a forensic scientist can take a fabric that has been dyed. They can put it through a spectrometer, and it will actually pull out the different colors that are used to make that shade of red. It would give us like, maybe it is 50% of the red, and maybe there's like a 10% blue in it and a 28% yellow. So anyways, the color of it. And if you were to want, say, several bolts of a specific color of material, you would want them to dye it all at the same time. Seamstresses and tailors will do this. If they've got to make a whole bunch of dresses, they want to make it out of the same lot that's been dyed at the same time, in case there's a slight variation in the formula, then the shades would be off. The next property, so the first was color. The second property is going to be the texture. That is the fiber rough or is it smooth? If you like to wear wool, well, sometimes wool can have kind of an itchy feel to it. That itch is the texture of the wool fibers. Now keep in mind, wool is actually the fur or the hair of whether it's alpaca or sheep. So you can see that there's a rougher texture to the one on the left and a much smoother texture to the one on the right. The one on the right is the nylon fiber, and you probably have some kind of a shirt. Sports fabrics are usually made out of a nylon, and so they are a much smoother finish. Next property is called crimp, and crimp is looking at whether or not the fiber is straight or wavy. Something that has a lot of crimp to it is going to be very wavy. It was a huge fad probably in the 90s where girls were crimping their hair. They had a crimping iron, and it didn't give your hair curls. Instead, it gave your hair like these little peaks up and down. So you can see the fabric on the right has a wavy crimp. Pliability is our fourth property. And you're taking a look at the crease. If it bends, it's pliable. If it does not bend, it's rigid. Or if you bend it and it keeps that fold or that crease, it would not be pliable. So thinking about a piece of paper, you can bend a piece of paper, but if you take and fold it and then rub that edge, it's going to leave a crease, and we would say then that it is not pliable. For most of us, our hair is very pliable, it bends, but if your hair has a lot of damage, the ends might not be as pliable. You can see in the pictures, it looks like maybe it's a broom, the bottom picture. And if you took the tines of a broom and bent them hard enough, they might be apt to snap. Our last property here is called resilient. And this is where forensic scientists would try and crush the fiber. So they would take it, they would pull it. If the fiber springs right back into shape and you can't see where you pulled it out, you would say it was resilient, it bounced back. If the fabric does not spring back, so if it leaves a little tiny, say, peak in the fabric, we would say it's not resilient. So we've got a link there to a video, and that video looks at something called the flame test. So after a forensic scientist has gotten the color, texture, crimp pliability, and resilience of a fabric, the last thing they would do is something called the flame test. And they always save the flame test to the very end. And sometimes they don't even do the flame test because it permanently destroys your fiber. Once your fiber has been destroyed, you don't have any solid physical piece of evidence that you can take into the courtroom. So watch that video, and next week you'll be doing the flame test with some pieces of fiber. That's all that I have for this week. I just want you to fill in those guided notes, drop them into my Dropbox, pop into my office hours if you want some help getting caught up on back work. All right, have a good week.